We will start with Jetton standard. Jetton standard, also fungible token standard, is number 74. And here in this repository with all the standards, you could have the whole description of how Jetton contracts must function. So you can see that there is two contracts. There is master contract or minter and wallet. So for example, here we see the specification of wallet smart contract. So the wallet smart contract has to be able to handle certain messages. For example, transfer, and then explaining everything what happens and what is caused by transfer. And then it has to be able to handle burn messages. And then it has to have the get method, get wallet data. So it has to return the data about itself. So this is like the main way to implement the wallet contract. And here's the master contract. So we don't put the code that must be there. We put the functionality that is actually supposed to be implemented in a certain way, so other contracts that want to interact with your contracts of Jetton, they would know exactly how to work with your contracts, because you will have master contract, the minter that is actually minting all these Jettons, and you will also have the wallet contracts for each of the users who are using your Jetton. And the external services, sometimes they will want to interact with your users' wallet contracts. And sometimes they will want to interact with your master contract, minter contract. So to not have to figure out every time how it works, and so for example, the wallets, they want to show balances, and they don't want to deal with each different Jetton type. So they just agreed on the standard of how they must function. And we assume that if something doesn't function like certain Jetton requirements that are explained here, it will not be able to be considered as a Jetton. So wallets will not consider it as a Jetton, and other services as well, like explorers. So you have to comply with these rules in order to be considered as a Jetton. And as I mentioned before, this is just a set of contracts. We've learned very basics of contracts programming, but here it is a much more complex logic, and reading the contracts of Jetton and like the master contract and wallet contract to understand, actually see how it works, this is a very, very beneficial thing for you to do, because this is how you actually practice your knowledge of how cells are composed, of what kind of complex logic you could actually implement in your custom contracts that are not even Jetton related, but Jettons and NFT contracts. This is an amazing way for you to actually learn what could be done, how the syntax could be implemented, how complex could be implemented some things. So what we're going to do now is we're going to dig into the code of Jetton contracts. Just like I said, we already have understood that there's two contracts. So we have an implementation that is like implementation, let's say the best practice. So you don't have to use this code. You could implement your own, but it has to comply with the standard. So here in this repository, I will also leave the link to this repository in the description. We will proceed to the FT folder, fungible token or Jetton. And here we see multiple contracts. So we see that there is Jetton minter, there's Jetton wallet contract, and these two we are going to look into the most. There's also more, something like Jetton minter ICO. This is just an implementation of initial coin offering functionality. We're not going to dig into that, but I really encourage you to look into this code, and this will show you so much about how complex the logic could be. And this will teach you a lot. And we will use a few more files like Jetton utils, because Jetton utils actually have a certain logic that helps the main file of Jetton minter. Also, we have OP codes and we have params. So these are just utility files that are helping, and we just encapsulate some logic to reuse it. So I'm going to clone this repository, and I'm going to dig into details of this code. Let's proceed. I'm cloning the repository of standard implementation. token contract. And we are going to dig into this code here. FT folder. And we will start with Jetton Minter, because this is the core contract that is initializing everything else. We will see that here's a storage scheme in the beginning. We already know this logic that we encapsulate the storage reading and storage saving data. So we could use this function anywhere in the code to ease the process of reading the data. So we have total supply. We keep the admin address, the one who is administrating the whole contract. So some messages could be accepted only from the admin. We see the content, and content is basically the data that describes the unique thing about the token. We will also have a look into the data standard, because there's also a standard of how this data should be, because there's like title, description, some other stuff. So explorers and other services were able to actually use your contracts metadata to show the users which Jetton they're working with. So, and fourth one is the Jetton wallet code, because you already probably know from the first lessons that contracts are, let's say, scaled. So we have one main contract, and this is Minter. And this Minter contract is actually deploying wallet contracts when it's minting something. And then wallet contracts are also able to deploy other wallets. So if I'm sending money to someone who doesn't have the wallet yet, I'm also sending it with code. So our wallet contracts will also keep the wallet code. And we will see that in a minute. But let me go to the standard repository, and let's see what is the standard regarding the data. So here we have token data standard. Here we have certain guides for example, this is NFT collection metadata example. And this is NFT IT metadata example. And here is Jetton metadata example, exactly what would be stored there, where we just seen it. And there's important to note that for off-chain content layout, so this is an off-chain example, like a JSON object, you would have to store the first byte should be 001, and it would mean that the rest is a URI that is pointing to the JSON. So you would basically say to anybody who is reading this data, say, look, I have off-chain data, so have a look at this link, download the JSON, and there you will find everything. But if you're storing it on-chain, that is also possible, you have to put the 00, and then you actually show that the K-value dictionary is stored in the rest of the memory. So this is basically some tricks on how to optimize it. You make your decision, but it's important so you know what is stored inside of this content cell that we're talking about. After reading from storage, saving data to storage, we are going to mint tokens. This is a function that is implementing mint functionality. We just define it here. Let's collapse it and see where it is used. The next thing we have receive internal, and receive internal is the core function for each smart contract. So here you actually read the first parameters of the message. We're going to explain it in a moment. And then you, based on the operation code that you received, you actually run some functionality that is more extended. So, for example, we kept the functionality of mint inside of this function. So we prepare some data, we read out something important. We're going to talk about this. And then we run this mint tokens function. So we don't want to put all this code here. And for example, for burn notification, the logic is quite simple. So we don't encapsulate it into another function. But here you see the core structure. So for example, I'm going to collapse everything and just overview everything again. So we have load data, save data, very simple, we already know this. Mint tokens, we're going to talk about this in a minute. We have some basic logic of handling the message that comes, like any message that comes. So we will talk about this in a moment. Then we have the mint logic that is going to actually, we'll prepare to run the mint tokens function. We have burn notification logic. It's a message that comes when some tokens were supposed to be burned. So this is the burn notification. And we have some administration logic. So for example, here we have operation code 3. It's like changing administrator. And you would just read the current administrator, you would compare it, and then you would save the new one. So this is something very simple we already can understand easily. Change content or delete, the possibility to delete this logic if you don't use the editable content, or if you want to make it editable, you can actually keep it here. And here the administrator would be able to save data with different metadata, as you can see. So this is something basic. This is just a little bit practice for you for understanding how complex it could be sometimes and what are the applications of what we learned in previous chapters when we were writing the contract. Yeah, and of course we have getter methods. So getter methods, again, quite simple. You just return whatever you read from here, and you make it available for the outside world. So you can get the supply, the admin address, the content, the Jetton wallet code, and get wallet address helps anybody to actually figure out what would be the wallet address for someone's address. So if, for example, I have a wallet and I want to get some Jettons, but I want to figure out what will be my wallet address once I get the Jettons, because the Jettons wouldn't come to the contract of my wallet. They would come to the deployed Jetton wallet contract, and I would like to figure out what would be my address then. This is the function that helps to do that. All right, so let's spend a few more moments to understand what is inside here. So in this logic, so it's quite simple. We don't want to handle the empty body messages, so we would return, finish the execution. Then we want to figure out what are the flags, so we can actually ignore all the bounced messages. We will also stop execution. Then we figure out who is the sender. Then we, at this point, we read everything that we wanted from the in-message full, because this is something very important for figuring out how we make it further. So now we read out from message body. We read out the operation code, query ID, then we get everything from the storage, and we start implementing our mint logic. So we know that we will throw a message error if mint was called not by admin. Again, it depends on the functionality that you want here, but this is not a standard. But the standard is that the mint function has to be implemented and it has to function a certain way. But you can make it open if you want everyone to be able to mint, but up to you. After this, we read out the in-message body that we get here. And as you know from the standard discussion, so we have here the standard of what is going to be in this message. So this is you cannot change, because people are going to treat your contract like it's supposed to be able to handle this. So here we go, Jetton Master contract. It's TLB schema. So yeah, it would basically mean that you have to handle this message with a certain logic, so with certain TLB schema. So it will always have the to address, the amount, some master message. So master message is the body of message that you're going to pass once you actually run the mint transaction. So, okay, so we read the destination address. So who should be the owner of these new Jettons? And then we say the amount. Then we say master message, and we start to read out the master message. And let's see the mint tokens function. So we would understand what happens to the master message there and what happens to this Jetton amount. So here you can see that Jetton amount is something that is already in master message. So this is a number of tokens that the user will actually get, because you already keep it in master message, because this master message you are going to pass to the contract that is wallet contract, right? So wallet will also know how much Jettons are coming with it. So here you increase the Jetton amount by this, but let's go to the mint tokens and see where this amount goes. So we open the mint tokens and we see that the variable amount actually is coming here. So The amount is the amount of real tons you want to pass along with your Jetton mint transaction. So you are actually able to control how many tons to pass further. So, for example, 10, you can ask person to send 10 tons to the minter. This logic you can really, it's up to you, because this basically regulates how do you actually distribute your tokens. So you either get payment, you can check here that there must be 10 tons sent for each Jeton to be minted, for example, or whatever. But it's important that you can control how many tons are actually coming and then are passing through to the next contract. Yes, you can see this here. So once you actually run mint tokens, some interesting logic has to be done. You get the to address. So this is the receiver. You get the Jetton wallet code. And you get the amount, as we said, the amount to forward this money, and master message, which is going to be body of message that will arrive to this new contract. So you remember how we were deploying our contracts, right? We were actually calculating the state init. And this is exactly what is done here, because this function is going to deploy new wallet. It's going to deploy new contracts. So we're using this function that is actually also available in utils. We have this function defined here, yes, and we are composing a cell with the state init. So as you remember, we were doing similar job there, but we're doing this in TypeScript. But now you see the similar thing happening here in FunC. So this is Jetton wallet code, and here you have to pack the data. So the data is going to be the initial data once the contract will be there. We're going to learn more about this once we will overview the wallet code in the next lesson. But here you're actually having this function to pack Jetton wallet data. So you will see that in the storage schema, we will see the balance, owner address, Jetton Master address, Jetton wallet code. So this is the moment when we're actually packing this cell and we're putting code and cell to form the state init, the initial state data. This is one function that we're going to use. Let's get back to the minter. So we are calculating the state init because we have to attach it to the message. And then we need to know where to send this message, right? So what is going to be the address of the contract? Just like we did in TypeScript, but here it would do the same thing, but inside of the FunC. So it's a great practice for you. So this to wallet address is going to be the destination where we're actually sending this state init, master message, and this amount. And we are going to use this function calculate Jetton wallet address. Let's see it here, calculate Jetton wallet address. And here we are doing something similar. So we are composing. So as you understand, we're talking that address will change if state init changes, but we can see that state init and the cell hash is not everything. It's not the whole address. There are certain flags. There is a work chain number. Work chain, by the way, we also use here from the params. So by default, we use the 0 work chain. But here you also learn how the address is formed. So this is what address is consist of, because TypeScript is kind of saving us from so much complexity, but sometimes you will need to understand this because, again, you have to be able to compose the same amount of cells. So you compose the cell with the address, so you would actually send it to deploy the contract. So this is why it's a very good practice for you to now see how the address is composed. And we do the same thing like we did in TypeScript, but here we do it in FunC, and you learn much more things with that. So we're basically composing the address. You can read into documentation about every bit and what it means here, like in this fourth, but this is work chain. This is the cell hash that means that the address will change if the state init changes, and the state init will change, as we can see here, calculate Jetton wallet state init. It will change if the code changes or data changes, right? So it's like a domino. So this is a cell, and if you want to read out it, you just start parsing it. So that's how you return a slice. And you remember the address is always a slice in FunC. All right, so let's get back to Minter. And yeah, so basically we calculated the state init, we attached it, we calculated the wallet address, we put the amount of tons we want to forward and send there, because from those that come to the mint transaction. And we also put the master message that is going to be actually internal transfer message. So they're going to arrive, like this message will be handled by the wallet contract when it comes. So we're going to talk about this a bit later. And basically, we just send this message. The last part that we'll quickly go through is the burn notification. And burn notification is basically when we get the Jetton amount that we want to burn. So we figure out what is the address that sent it. And we have to use this function, calculate user Jetton wallet address. So let's see what it does. So someone is sending the message with burn notification. We figure out how many Jettons we should burn. And then we check from whom this burn notification is coming. So let's see this function in the utils. So you see that here we are calculating state init of owner address. Let's get back to the minter, just so you see. So from address is going to be owner address. My address is the address of this contract. So my address is our minter, let's say. And then we have Jetton wallet code. So we pass we check that the results of this function, calculate user Jetton wallet address, we check that it is the same as the sender address. So whoever is sending this message from address is like from whom we should burn this Jettons. So we will actually calculate the wallet address of this user, and we want to make sure that the wallet address of this user is going to be the same as the sender address. And then we open this function and see what it does. So it's basically using the other two functions that we already know. So it's calculating the address, it's getting the state init, so the out of owner address that we pass here, the Jetton Master address, that is actually this wallet's, this contract's address, and Jetton wallet code. So we calculate the state init. Out of the state init, we calculate the Jetton wallet address, and this will make sure that the one who sends this message is the owner of the contract that we're going to actually burn the Jettons from. All right, so once we do that, we actually deduct from the total supply the amount of Jettons, and we save this data. So now in the storage, we can see the less amount of Jetton in supply. And then we read the response address. So there in body, according to the TLB schema, there is going to be response address, like whom should we deliver the rest of the tons that are there like with the accesses operation code. So here, as you can see, we start forming body immediately here. So we're composing a message that is not able to be bounced. This is why this shortcut is changed, as you can see here. So it's like it changed a little bit. It's going to be like hexadecimal 0x10. Yeah, so basically we just use the 2 plus 64 row code. So we send out all the money that came with this message. We just send them out to the response address along with operation code accesses. So basically that's it. We've seen two contract message like handlers, and we figured out that this is just a contract. So Jettons, nothing magic. It's just a contract with a certain logic, and this is going to give you a lot of benefit to simply just read how the contract works. And in the next lesson, we're going to read about Jetton wallet. So you're actually going to see it from the other side, how the wallet interacts with it, right? And the next lesson, we can actually return to the minter sometimes to see some logic, and especially with this deploy logic, right? So I wish you good luck with learning this logic with the repositories. We're going to leave the links to these repositories in materials. And see you in the next lesson with the Jetton wallet contract code review.